Today we're going to talk about solving inequalities and graphing their solutions on a number line. I'm looking at problem 5-65 on page 294 in your book. And the first thing that we're going to be doing is we're going to be looking at this on an equation mat. And if you remember, for the last couple of days we've been working on these expression comparison mats, comparing two expressions to find when one is larger than the other. We are going to continue to use those expression mats to look at this expression. So the first step would be to draw this expression. So go ahead and draw this in your notebook. Go ahead and hit pause while you're drawing. So now that we're solving these, instead of just comparing them, our goal has changed a little bit. We now want our x to be by itself. So we want to get rid of the unit tiles that are on the same mat with the x. So if I'm looking at these 5 unit tiles, how am I going to eliminate them? Well, if I have a positive 5 unit tiles, the only way to get rid of them is to make 0 pairs. So to make 0 pairs, I would have to put on the same mat 5 tiles that are the opposite of those, which would be negative tiles. But because I'm doing that to mat A, I also have to do that on mat B, because I just can't add whatever I want to mat A and not change mat B. We have to keep it balanced. So I also have to put the same number of negative tiles on mat B. Now we're ready to make 0 pairs. So that took care of everything that was with the x's on mat A. On mat B, we can make some 0 pairs here, and I can get rid of these 3 negative tiles and these 3 positives. That leaves me with -2 on the right-hand side, or on mat B, and that would be greater than the 2 x tiles that I have left on mat A. So what I had was 2x is less than -2 after I got rid of my unit tiles. So now I have a new mat, and I have 2 positive x tiles, and I have 2 negative unit tiles. So if I were to, I want x by itself, and 2 is being multiplied by x right now. So I need to divide these x's up. So if I were to divide everything up, I would be left with an x is less than, I'm dividing everything by 2, -1. Because I'm dividing these 2 x tiles by 2, and I'm dividing this -2 by 2 as well. So this is the answer, or the solution to this inequality. X is less than -1. The original problem was 2x plus 5 is less than 3. So the solution to this inequality is x is less than -1, which means that any number that is less than -1 will make this inequality true. So let's try it. Any number less than -1. So numbers less than -1, that would be -2, -3, -4, -5, and so on. So let's just choose one of those values. -3. 2 times -3 plus 5. 2 times -3 is -6 plus 5 gives me -1. Is -1 less than 3? Yes. It is. That's true. So our solution that we got of any value that's less than -1 will make this inequality true works. Let's look at what this looks like on a number line. Alright, so we are graphing the solution. Whenever we have the less than symbol or the greater than symbol, these two symbols, we use what's called an open dot on our number line because it means it does not include the solution. So I'm going to put -1 in the middle of my number line, and I'm going to put 2 values, one on either side. So -1, what comes next when I'm counting is 0, and one number less than -1 would be -2. So I'm going to put an open dot at -1, and I think I'm going to change colors. So open dot at -1, and the numbers that make the inequality true, we said, were -2, -3, and so forth, so I'm shading to the left. So that is how we graph an inequality.